two parallel loops of 3 resistors each. It should tell you a lot about the circuit right there, right?
Oh, yeah. Just talking to me.
Okay. So it looks like we're gonna have to do 1, 2, 3, 4, 5, and 6. So we're gonna have total 1, 2, 4, 5, and 6. And we have voltage, current, resistance, and power. Okay, it's starting to die. Okay. And then we've got some givens. Okay, for number 1, we've got a voltage drop of 8.528 volts, as well as 0.6214 volts. Here we've got some milliamps in current, so let's just convert it right now. 13 milliamps, which would be 0.1322 amps, as well as 57 milliamps, which can be written that way. Looks like 8.5. All right, and then down on the lower, oh, we also got some resistances put here. 82 ohms and 33 ohms. And then we got some power values here, also in the form of milliwatts, 2.6 milliwatts, which would be 0.0026 watts, and 111.1 milliwatts, which would be 0.1111 watts, right? Okay. Some observations that we could make about the circuit. Given how low the resistance is and how low the current is, the voltage probably isn't going to be very high. It's probably not going to be 10,000 volts. It's probably not even going to be 100 volts. Just sort of from the get-go say it's going to be 10 volts or 5 volts or 12 volts or something like that, something pretty low. The voltage drop of 8.5 tells you it's got to be above 8.5, right? However, then the voltage drop across 2, that isn't very much of a voltage drop, right? So whatever's left over coming across 1, 2 can't be that big of a resistance. It's going to be a pretty small resistance. And in fact, you can kind of guess that all the way across the board. So in terms of analysis, before we analyze the circuit, although the circuit isn't that hard to analyze, is it? I mean, you've got 3 resistors that can be combined into 1 by addition, and then parallel to 4, and then all of those values added up. So analysis is add up the series, parallel to 4, add up the series. That part isn't going to be too difficult if you knew all the resistances. However, before we do that, we do have column 3 and column 4 where we can solve for the power in each one of those and the voltage drop in each one of those, right? Because we have 2 ingredients, right? So that times that, going to be a small number. That times that, also going to be a small number. Let's see, survey says, well, a couple of cases of pretty close to just a volt, a little over a volt, 1.084 volts, and here, this is almost 2 volts. Whoops, I said 2, and I meant to say 9, so it's almost 2 volts. All right, I can also calculate downwards, volts times amps, and survey seems to be about 0.142 watts, as well as here 104, yeah, 1104 watts. Now, note that because I'm dealing in fairly small values, it's particularly with the amps, I'm probably going to want to carry the decimal place out 4 or 5 places. If I round this up to, to 0.06, I'll have changed that number significantly. Okay? Or even worse, if I round this up to 0.1, now I've changed the number by 70%. Right? So probably don't want to do that. All right. So let's see. One thing we could do pretty quickly here without too much analysis, isn't the current that's going through 4 and the current that's going through 3 the total current?
Total current.
Right? Some of the current's going this way, the rest is going that way. So I could theoretically add up the current in 3 and the current in 4 and plug that into 6, 1, and total, right?
Yes.
Wouldn't that be the simplest way to go? Now, then I'm going to have plugged in a whole bunch of stuff. Okay? I can also say that the current that's going through 3 is going through 2 and 5, correct?
That's correct.
So I can just plug those in right now. Amps, that was 5, right? Yeah. 0.01322 amps. Then let's see if we had this mess up. 22 to 85 is going to get us 107. So 107, oh, that's getting ugly, isn't it? 107 is going to carry us up to 4 plus the 1. I'm going to have to do it. I'm going to have to do it longhand. I lost it. 0.132205785. Okay, 7 there to there gets us to a 0 and a 1. Gets us to a 1 and a 1. That gets us to 7. We're still at 0. Okay, now I can plug that in the rest of the currents, can't I?
Yes.
0.07107 amps. There, decimal place there. What is that? There's a train coming through the building?
It's a soul train.
So pretty.
Dang. So from here, we don't have to do any more analysis, do we? Don't we have 2 ingredients in every column? It's strictly a math problem from this point on. Probably the only thing you might want to do is, whenever you're done, refigure the resistance back to here, and then calculate it from here, and make sure they're both the same. That tells you, and a lot of you guys, as I grade these, it's clear you're not doing that. It's clear you got a number of them wrong, And had you just done that check, you would have known, oops, this doesn't work right. Okay? All right. Right, so I will, let me hand this out and then I will hand out your last week's one.
Well, you gotta take a test.